Welcome back once again. Like what I promised, I'm going to do or to discuss solving systems of linear equations in two variables by elimination. The idea of elimination, the word eliminate, gives us the idea that we're going to make something disappear. It's like to erase or to eliminate. For example, if you go and have a competition, you have to eliminate your competitor so that you will win, something like that. It is the same idea here, but we're going to use either addition or subtraction on the way. But we usually use addition. How to do it? There's my cursor. I cannot see my cursor. All you have to do is you need to make one of them into different sign. So for example, I have positive 3 on the first equation, then I need to have negative 3 on the second equation, so that I can eliminate them, because when I will add them, this is pain. When I add them, it will become 0. That's the idea here. Right now, 2x and 3x, if I'm going to add them, it is not 0. It's the same with 5y and 8y. If I'm going to add them, then it is not 0 either. So I need to do what I need to do. I will find something. 2x plus 5y is equal to 41. I will decide which variable I want to eliminate. I will do the easiest first, but you can do whichever. So I want to eliminate x at this time. So if I'm going to eliminate x, I need to have this one negative and the other one positive. So that when I will when I will add them, then it will be 0. As of now, it is not 0. So if you remember your least common denominator, it's almost something that you need to apply here also. So 2 and 6, the least common denominator for them is 6, isn't it? So if I'm going to multiply 3 by negative 2 and 2 by 3, but be sure that you're not only multiplying the first the term that you want to eliminate, you have to multiply all of the terms. So this will give us now, if we multiply 3 by 2, then it will give us, I need a pen, 6x, and then plus 15y, and then we have 123, I hope that, 3 and then 12. And then the next equation will give us negative 6x minus 16y is equal to 0, 12, 13, 130. That is negative 130. So that if we will add them, this will become 0. Then we only have y to take care of. That's negative y, negative 7. By multiplying both sides of the equation by negative 1, or dividing both sides of the equation by negative 1, then we have y is equal to 7. So our answer here, y is equal to 7. Then you can use, of course, substitution to to find 4x. So if I'm going to use 1 now, use 1. I cannot see my cursor, that's the problem. I'm going to erase those. Okay. Then we have 2 times x plus 5 times 7 is equal to 41. That's 1. 2x plus 35 is equal to 41. If we subtract both sides of the equation by 35, then we have 2x is equal to, what will be 6. We divide both sides of the equation by 2, then we have x is equal to 3. And x is equal to 3. That's our solution. But as I've said, I can also eliminate y. So we're going to eliminate y. We have 2x plus 5y is equal to 41. And we have 3x plus 8y is equal to 65. As you can see here, 5 and 8, they will meet in 40. So if I'm going to multiply this by 8, and this is by negative 5, then I will get this 16x plus 40y is equal to 8, and then we have 32. The next one, we have negative 15x minus 40y is equal to, we have 5, and then we have 30, 325. That's negative. So if I'm going to add that now, y is 0, 40y minus 40y is 0, and we have x is equal to, what will be? 3. So, as we got there. So you can choose pure elimination or just eliminate 1, then do the substitution. We'll get some example. Here's another example. 4s plus 90 is equal to 43. And then 3s plus 70 is equal to 26. And we can eliminate the s first, and then on the other side we can other side of this we can eliminate t instead. So eliminate s first. 4s plus 90 is equal to 43. Then we have 3s plus 70 is equal to 26. So to eliminate s, I have to multiply the first equation by negative 3 and the second equation by 4. Then I will get 12 negative 12 s minus 2070, that's minus, is equal to negative, that's 9, 129. 4 times 3 is 12. The next equation, we have 12s plus 28, t is equal to 4, and then 8 plus 2, 104. Adding, that's 0, and then we have positive t is equal to, what will be? 5, 25. It will disappear, 25. T is 25. So our solution here, we have t is equal to, and t is equal to 25. and then the next will be s. Okay, the next equation. We're going to eliminate the t this time, not s. Did I do wrong? 24, 8 plus 2 is 10, 104. Okay, so we have 4s plus 9t is equal to 43. And then we have 3s plus 7t is equal to 26. So if I'm going to multiply this by 7, so it's negative 9. As you can see, it doesn't matter where I put my negative as long as they will be positive and negative. And their numerical coefficient will be the same. Just the sign is the different signs. We have 28s plus 56, I hope. No? Nine times 7, 63, sorry. Not 56, 63. T is equal to, we have 1, then we have 28 plus 2, 30, 301. And the next, we have negative 27s minus 63t is equal to 9 times 6, 54, 9 times 2, 18 plus 5, 23, negative. So we have, this is 0, and then we have s is equal to, what will be? We have 7, this becomes 9, we have 67. I'm going to look if I did right, or I think I'm going to use my calculator maybe to calculate first before I said that's the answer. Okay, because I didn't solve this before. Now I can say that I did it right. S is equal to 67. Another example. Let's try this example, a little bit different, but I hope we can manage. Let's see. This is our equation 1, and we have this equation 2. As you can see here, we already have, we already have positive and we have negative there. So if we're going to eliminate y, then I have to make sure that they are the same, not 1/4, not 1/6. What can I do is, I might multiply this by something to make it 1, and this one to make it 1. Then I'm finished with that. Let's try. So we have x divided by 3 plus y divided by 4 is equal to 1/12. Then we have x divided by 2, and then y divided by 6 is equal to 2/3. So if I'm going to multiply my first equation by 4 and my second equation by 6, then this will become 4/3 x plus y is equal to 4/12. And then the next is we have 6 divided by 2x minus y is equal to 12 divided by 3. So this now is equal to 0. And all you have to do is add that. We have thirds plus 3. That is 3 and 4 thirds x is equal to, this is also equal to 1/3. So if we have 1/3 plus 12, that is 13, 3. Okay, if we express this in proper fraction, then we have improper fraction. I should say improper fraction. Then we have 9 plus 4, that is 13. X divided by 3 is equal to 13x, 13 divided by 3. As you can see now, if I'm going to multiply both sides of the equation by 3, now this is equal to 1. And if I'm going to divide both sides of the equation by 13, so divide by 13, divide by 13 there, this one will become 1 also. So my x is equal to 1. So x is equal to 1. How about if we're going to eliminate x? So we have x divided by 3 plus y divided by 4 is equal to 1/12. And then we have x divided by 2 minus y divided by 6 is equal to 2/3. So if I'm going to multiply my first there by 3, and my second by -2, then I have 1 plus 3/4. Y is equal to 3 divided by 12. Then if I'm going to multiply, that is 1x. And then we have negative 1x also. And we have negative 2/6. Y? A positive. Sorry, because it's negative. And then we have negative 4/3. Yeah. And this one is equal to 0 now. 2/6 is equal to 1/3. So if we have 3/4 plus 1/3, then we have by 4 there by 4, by 3 there by 3. Then we have 9 plus 4, that's 13. 12. So we have 13, 12 is y is equal to, since we have 12 as our denominator now, then I need to use that also. 3/12 minus 4/3. So if I'm going to multiply this by 4, then we have 3 minus 16 is 13, negative 13 divided by 12. That is negative 13, 12. As you can see now, this is equal to 1, so we have negative 1. So our y is equal to negative 1. You can check. So if x, we can use 1 to check our answer, or we can use 2, both. So we have 1/3 plus 1/4 is equal to 1/12. Oh, negative, minus, plus negative there. So we have by 4 there, by 4, by 3, by 3, then we have 4/12 minus, is that equal to, minus 3/12. That is equal to 1/12, of course. You can try the next one. Yeah, I hope you learned something about solving systems of linear equations into variable by elimination. next time I think I'm going to do the linear systems of linear inequalities in two variables. See you soon.